Okay. So I think we are ready to start. I just have to start by saying it's a pleasure to be back here at Purdue. I went to Purdue for undergrad, so as I walk around the student union, it brings back memories, let's just say. But let's go ahead and start. We have 5 exceptional panelists here to talk about chips and looking at taking the pulse of the Heartland's chip boom. So I'll ask each panelist to start by discussing the Indiana-Illinois corridor. In particular, what factors have positioned the Indiana-Illinois Innovation Corridor as a hub for the research, design, and manufacture of advanced semiconductors? And as you give your answers, it would be great if you can also briefly describe your background and experiences to help frame the context for your answers. So with that, we'll go ahead and start at the far end. We'll start with Bill.
First up, thank you very much. And thank you for having me. This is a fantastic opportunity. Appreciate the opportunity to speak with all of you about a very, very important topic, which is bringing back the chip manufacturing here to the United States. A little bit about my background, Bill DeVries from Dassault Systems. Dassault has been a long-standing partner with Purdue. We make CAD, CAM, PLM software for the, I think earlier today they were talking about we have to have acronyms. There are no more, there's no larger area than software to have acronyms, and so yes, we have a bunch of them. Product lifecycle management, 3-dimensional and 1-dimensional CAD is what Dassault does. So we're producing software that enables engineering and innovation. And one of the key areas that we're focused on is around semiconductor design, fabrication, and manufacturing. And so it's a pretty key role for us, and it's been a fantastic partnership that we've had so far. So as far as the corridor and why is this area uniquely positioned to have an impact in the manufacturing of chips? For me, my background, I run our academic sales as well as our direct sales, half of our direct sales for North America. The key for any big transformation, and that's really what we're looking at on a very large scale, is a transformation across the United States to bring this manufacturing back. And the 4 key areas for transformation for me: people, process, technology, and cost or money. And obviously the money, I'll start there. You can see there's a lot of money that is flowing into this from the U.S. government. The CHIPS Act, we heard $52 billion. We've seen a lot of the leadership that is here responsible for dispensing that money. And it has been something that all of us are looking at. How can we have an impact and bring back and help our national security by focus on this manufacturing area? So that's the cost part, is how can we all have an impact on that? How can we help our own companies? If you're associated with the commercial side of it, from an academic side, how can we bring students and skill up the workforce that's needed? And that's going to be absolutely key. From a process standpoint, you heard earlier today, chips were made and created here in the United States. We don't need to understand how to build, how to do the process of manufacturing a chip. What we need to do is get the people that know how to do it and to do more innovation. It's not going to be, we will not be competitive just simply doing the process the same old way. We're going to have to find a way to do it more efficiently and more effectively, more cost effectively. And so I think that's going to be one of the other challenges that we have. Then from a technology standpoint, that's where Dassault Systems comes in. I was talking with a couple of the colleagues here in the green room about what we do, and most people have heard of a digital twin. Well, a digital twin implies just a snapshot in time. Imagine you take a picture. It's a static snapshot. What Dassault Systems does, we have a live platform that interacts all of the physical models, the form, fit, and function, as well as the simulation real time. All the data is live. So no longer do you, as a matter of fact, we don't even have a file that you have to open up and translate to other files. So all the data being live, what that allows us to do is, if something happens inside this process, if something happens in the virtual twin, not the digital twin, but the virtual twin, the system will know it, and it'll tell the user exactly how it's going to react and interact, whether that's in the design phase or in the manufacturing phase. And so that's what the technology piece is so critical for, and that's what we do. Lastly is from a people standpoint, I think it's one of the biggest challenges that we have, and I think it's one of the things that Purdue specifically, and I know there are other key universities here in the Midwest that do this as well, but Purdue has, with the leadership of President Chang and Christina and a lot of the other faculty here at Purdue, what they've done is they've seen a vision that they need to create a new student that will allow this design, manufacturing, and fabrication of chips. They've created their own curriculum. We sit on the board with them. We're partnered with them in this area. So this has been something that has been key for us, and I think it's one of the biggest challenges we have is today there are no people that are doing this, manufacturing. You heard President Chang mention earlier today that only 9% of the chips today are produced here in the U.S. That means 91% are done at scale offshore. We need to repatriate that and bring that back. So lastly, what I'll say about this topic is the partnership that we have with Purdue. We formed one with the Burke Center. Jion Chen is the leader there, and we've started working on creating these virtual twins. We've got 2 of them. One for a clean room, and so through a partnership with Apple and their Vision Pro, you can immerse yourself as a student inside the clean room, and you can go in and you can walk through and you can simulate. It'll show them what it's going to look like, and it's real time and it's all interactive data. Which is very key. And then the last one is we're working on is a gowning process. So what we're trying to do is go through every phase and every step to create virtual twins throughout this entire process, so students can be immersed inside of this experience, if you will. And that's what we've been working on with them. So I think that's how Purdue and this corridor is uniquely positioned. Is we're already starting to work in these areas and having impact on the student body with the help of the faculty.
Thank you, Bill. Such passion. Thank you. And Patrick?
Thank you very much for having me. Thank you to Purdue and the University of Illinois system, working with our partners at Compete for organizing this conversation. It is really fun to be back at Purdue. I've been doing it a lot. I used to work for one of the biggest employers in Indiana. I worked for a politician from Indiana. But it is really fun to be like a radical. When I was in college, I was not a radical. I was very conservative. But it's fun. The most radical thing I do is walk around the Purdue campus wearing a tie. As a tech guy, I always keep them really unsettled at headquarters by wearing a tie, which no one wears a tie at headquarters, and it's always fun to be like, oh, that guy from DC is here, which is always fun. So as you said, I work in the technology space in DC, so what I do all day is explain technology to politicians and the obverse, the politics to engineers, which is equally hard. I don't know, you can guess which part of that job is the harder part. But the thing that I'm immensely excited to be here about today is really the answer to our top question. Why would a company like MediaTek, the 5th largest fabless company in the world, a $15 billion company, last year we sold 2.2 billion devices worldwide. We're in 80% of all American homes, half of all the pockets. So if you have an Android phone, it's a 50-50 chance that our logic chip powers that. But we're probably 2/3 of all televisions, about half of all Wi-Fi connected devices in the US. So it's very funny because often in places like that, people are like, oh, who's MediaTek? I'm like, yes, like most semiconductor companies, I'm delighted to be joined by my fellow executive from another chip company here in Indiana, but we're kind of inscrutable, right? Where our technology is embedded in everything else, right? And because we're a little bit invisible, it makes it harder for young people to decide, oh, I want a career in that because it's remote. The idea of being in the semiconductor industry is remote because we're technology embedded in everybody else's product. So back to the high-level question, why in 2021 did MediaTek decide in the middle of COVID that Purdue was the place we wanted to be? We opened our 9th office in the US. We've been in the US for 25 years, but we decided to open an office here, and I want to give full credit. The answer is vision. Visionary people in Indiana. I will make a shout out for Governor Holcomb, who made the effort to fly to Taiwan. He came to our board meeting for the Semiconductor Industry Association in California, and he made the pitch for Indiana. And what really resonated, and this is what I would like for you to take away from our conversation here today, is that even with all the cheerleading of the last panel about how this is the innovation capital of the world, the really undisputed truth is that within about a 4-hour drive from where we're sitting are 5 of the leading engineering schools in the world, right? We have been hiring people from this region since day one. The president of our company is a Purdue alum. The president of our company's kid just graduated from Purdue with an engineering degree. Nobody in the tech sector has to be reminded about, and for that matter, Illinois. I urge you to go look on LinkedIn, right, and look at MediaTek's nearly 1,000 employees in the US and look how many graduated from Illinois universities, right, because they have great engineering schools also. The real difference and why we're here is that kind of the world has changed. As a result of COVID and a lot of other changes, instead of what we have been doing for the last 25 years of recruiting brilliant engineers from Midwestern universities and then insisting that they move to really expensive, crowded places like Austin, San Jose, San Diego, Boston, and Seattle. We have offices in all of those places, and if my HR was here, they wouldn't be happy with me saying that. But the truth is, right, it's expensive and difficult, and you may have to send your kids to private school. And the pitch that Governor Holcomb, and I will also say the former governor, the former president of Purdue, as well as the current Purdue president, made the case, hey, you can buy a really awesome house here, and you can send your kids to public school, and you have a really nice commute, and it's a great quality of life, and you can contribute and be part of a global team. That was the pitch for the Midwest. And for us, we're not a manufacturing company, we're a design company. That kind of clicked because we realized, why force somebody who lives near their grandparents here in the Midwest to move to Austin or San Jose? They're great, they're cool, but it's really expensive and you're far away from your extended family. And so it makes sense now in the ability to contribute from anywhere in a global team to offer opportunities. Not every student who graduates from Purdue or from Illinois, for that matter, wants to stay at home, right? Some of them want to, but a lot of them do. And if they have the opportunity to design world-leading technology in their own backyard, we think they'll say yes. So that's the project that we're involved in here at Purdue, which is to get more young people who are getting advanced degrees in engineering to stay here.
Thank you. And Christina, about the Indiana-Illinois corridor?
Good morning, everyone. I'm Christina Farmas. I lead the Office of Industry Partnerships, and I am delighted to welcome you to Purdue and learn more about what we do. For the last 3 years, I have been supporting the semiconductor efforts at the university, and I can tell you that we have over 70 faculty members across all areas of the university that work in this space. They do research and they teach courses in microelectronics and semiconductors. So to me, that is one of the leading factors why we are positioned to play a significant role in this area. As Patrick alluded to, and Bill, we have exceptional facilities. One of the largest academic clean rooms in the nation is right here on the campus. I understand many of you will have an opportunity to visit it later today, and I'm glad that you'll be able to witness how we do research and how we train our students in world-class facilities. The other reason why we're well positioned is the way we deal with industry. We are extremely business friendly. Leading the Office of Industry Partnerships, I have come to realize that in the last 12 to 18 months, within a driving range of an hour, maybe an hour and 15 minutes from Purdue University, over $20 billion of investments from industry were made in this area. I'm referring to the Lilly over $9 billion investment just in Lebanon, about half an hour away from here. I'm referring to the investment from SK Hynix in the Purdue Research Park, about 10 minutes away from here, close to $4 billion. Pretty much all the large partners we have in the area have announced investments: Saab, Caterpillar, Evonik, Novartis. The semiconductor industry is one that enables all these industries. In our office in industry partnerships, we work with each one of these companies to make sure that we cater to their needs, to their talent, to their innovation, to their strategic direction, and that they find solutions right here, walking distance, driving distance, right here at Purdue. Thank you.
Thank you. And Woon-sung?
Thank you very much. And so that our really so expressed to gratitude for the acceptance for SK Hynix, a family in Indiana State and Illinois State, so residents. And also, we are here inside of Purdue. And this is just very important for us because that, so these days, semiconductor industry is just developed by some kind of scalability. We just focus on then the very smaller scale every year. But these days, we have faced very big barriers about the nanoscale area. So that, because that is just dependent very expensive equipment and very expensive technology by using, so we just call that EUV lithography, extremely ultraviolet equipment. Just one equipment price, $0.4 billion. Wow, just one. But we need so many equipment for the guys. So these days, our semiconductor industry develops two directions. First one is just we focus on the scalability by using EUV. The second is just advanced packaging. We just call that heterogeneous integration because that, so we just save the R&D cost and also manufacturing cost. Heterogeneous integration is just one of the key solutions. But as that terminology is just very confused. What is just the advanced packaging? Packaging is packaging. What is just advanced? Nobody knows that. So I always explain that of those kind of advanced packaging, these kind of things, SRRS. But expertise, even though they do not know how to manufacturing with our equipment with so those kind of very high productivity in HBM for SK Hynix. We just make some kind of breakthrough the technology by using, we call that disruptive technology in so many kinds of things. And by using 12-inch wafer fabs. And so, first runner got up, dominates whole markets. And in this case, SK Hynix dominates HBM market in the world. But we need so many kinds of resources to the kind of explore infiltration in every kinds of that technology directions. But our own SK Hynix resources is just very limited. We need a lot of helpness supporting further resources by as this kind of excellent Purdue or Illinois State University, or also very talented workforce from Ivy Tech. We just discussed about those kind of things. In this area is just very, very important area inside of America. And so we call that Silicon Heartland. That is just a real. Thank you.
Thank you. The Silicon Heartland. And it's a product about the
Hi.
Illinois.
Good morning, everyone. I'm Supratik Guha. I'm a scientist at Argonne. I'm also a professor at the University of Chicago at the Pritzker School of Molecular Engineering. And I've been in the Midwest now in Chicago for about 10 years, and I spent 20 years prior to that at IBM Research, where I worked on microelectronics quite a bit. I'm glad to be back in Purdue. I did not go here, but I have many friends and colleagues. I used to stay at the Union Club Hotel, but I found this time I can't afford it anymore. But it's always great to come back here. If I look at the Illinois, Indiana corridor, right? If we look at this region, the technologies it's developed, it's famous for is food, transportation, health, and the medical industry. And now it's put its feet forward in the direction of information processing for the future. Right? And information processing in the future is going to be a meld of many different things, right? Classical computing as we know it, quantum computing, you're going to see the merger of these two going forward. Classical communications, quantum communications, sensor networks, distributed information processing. And if you look at us, Illinois-Indiana corridor, there's a tremendous focus on beyond silicon, as the chancellor said this morning, in the Illinois region, in quantum technologies. There's the South Works site, which is very close to the Indiana border, a little south of Chicago, where the steel plants used to be, where the quantum foundries and the quantum site is going to be set up. I believe Harley will hopefully talk about it later today. And of course, you're seeing what's happening in Purdue. So I think it's time for us to leverage these strengths together collectively, right, and build this up as a Midwestern pillar of strength. One area of focus, all of this is undergirded by some of the top universities in the nation, right? Collectively, this place together sends, I believe, more semiconductor engineers to the semiconductor industry than any other schools. Right? It's also undergirded by 2 national laboratories collectively who have annual budgets of close to about, I'd say, $2 billion or so. Right? So it does the science at scale that Paul Kearns referred to earlier. So that's what we're capitalizing on. Right? One of the areas that the universities and the national labs can provide is the science part of the CHIPS and Science Act. Right? There's a lot of focus on the CHIPS technology piece. We can't leave the science behind. Right? The other part is energy and sustainability, and the connection of microelectronics and quantum technologies that will have to follow the guidelines of sustainability. Right? This is also, so let me ask you a very quick question. In the old days, we all used to know, for people around my age, we all used to know how many gigahertz or megahertz your processor was on your laptop. How many of you even know or care about that today? Right? But we all know how long our battery is going to last on the laptop. Right? And that goes across scale. You take the Aurora exascale that's at Argonne today, it consumes about 50 megawatts of energy, give or take, a few megawatts. When we go to the Zeta scale machine, right, we're not going to be consuming 50,000 megawatts. So that's the energy challenge, right? My friends here in Purdue, Kaushik Roy and Anand Raghunathan, keep talking about how, this boom in AI is consuming huge amounts of energy. Sustainability is going to go hand in hand with this. This is where the Department of Energy, National Labs, et cetera, come into place. Right? What we used to think in the old, philosophers talk about this concept of givenness, right? The earth, the mountains, these don't change. That concept of givenness itself is morphing because of information, right? Information processing. That's where we are headed, and I think this is the place where we collectively have the strengths and the capabilities to really move forward.
Thank you. So this was excellent to hear from the partnerships that are important in the Indiana-Illinois corridor in terms of the universities, the national laboratories, also the industry, but also looking at the people. So that's your students, your researchers, also the professionals. So now let's have a focus too, looking at some of the challenges. And that is, and I think, Sapradak, you started that discussion too, looking at some of the challenges related to looking at energy and sustainability. So I want to start with you as we look at that ecosystem that's needed to bring about the Indiana-Illinois corridor and this whole, relationship among all the different parts. What do you feel are some of the challenges around the research, the design, and the manufacturing related to semiconductors?
So I think with semiconductors, right, we're sort of, so far, as many of us know, we've progressed by scaling things down, right? Literally every 2 years or so, we would go to a Xerox machine and press 2x shrink, right? And then we'd proceed. And we're running out of that now, right? So the challenge is in what takes its place. This is where the science comes in as well, right? If I look at some of the mandates, right, there is the Paris mandate for industries, which asks it to reduce its emissions by a factor of 2 every 10 years. For a growth industry like microelectronics, trying to achieve that is going to be even more difficult, right? This is a huge, huge challenge. Some of the things that we're facing is how do you shrink devices, to points where these are in atomic dimensions. You're going in 3 dimensions instead of the flatland approach that we worried about. But we don't have a clear understanding of the interactions of the different excitations of how to get heat out of such, highly dense, energetically dense volumes, etc. So we need to develop this basic science that is sustained long-term research that is not publication focused, right? This is one of the biggest challenges for microelectronics today, is that we, the academics and the national lab scientists, are focused on papers. And it's starting to hurt this field, right? We need to be able to develop the kind of basic research that, places like Bell Labs and IBM did 40, 50 years ago, but they can't do it anymore because the business models have changed. But today's transistors, for instance, the Mark Lundstrom in a couple of decades, maybe 30 years back, developed a lot of the transistor device models that we use today, right? Ballistic transport, etc. Who's going to develop these things that we need 10 years from now? Right? This is the challenge for us right now, where we need to take a leadership. And I think the opportunity is here.
Thank you. And Woon Sung, if you could answer about challenges as well.
Yes. So in my case, the first challenging is just that me and SK Hynix will build some kind of ecosystem for supporting our 12-inch fab, because that so 12-inch semiconductor manufacturing fab is like an enormous equipment. So many kinds of things from the outside for supporting those so many. We need them, so very lot of companies to support for our manufacturing, and so the others so operating this kind of enormous equipment. And so firstly, I talk about that so many equipment suppliers and material suppliers to talk about that. So please focus to see this Indiana State, West Lafayette, and please give us your supporting for those kind of happiness. And so, as you may know very well about that, the applied materials or land research or the other guys, they are now focusing to see this area and how to make some kind of supporting system. So we call the eco chain system. So we are now discussing about those kind of things. So we will build those kind of ecosystem for our semiconductor manufacturing. Also, the other thing is just that R&D, research and development. So because that, so SK Hynix has a very excellent products for AI, HBM, and so our advanced technology for that. As you know very well about the mega companies, they are now interested in this new West Lafayette fab, because that this is located inside of America, not the outside. As we talk about the many kinds of things about dependent, so very secure issues, confidential, so technology issues, we'll discuss it. U.S. government, well, they did many department, they are now pushed to us to discuss about those kind of things, or our customers, mega company, they are now also discussing about those kind of things. So the other thing is just that these days, data center or so big guys, they are just adapt our HBM for that AI applications. But the mobile case, so very lot of mobile company, they are now interested in the so AI application by using our TSV infrastructure. This, we call that advanced packaging fab. We just so based on our elementary technology is just a TSV, and so they are now devised those kind of mobile application by using our basic infrastructure. Those kind of very helpful to save the cost. So this is just a big opportunity to us, SK Hynix, and so so thanks to your contribution to build our new fab in this West La Palette area, and so that so we'll make together those kind of successful story here maybe. Thank you.
Thank you. And that leads us to talking about, too, as we talked about challenges, to also talk about benefits and opportunities. And so I'm going to ask Christina if you could talk about what would be some of the benefits and also the opportunities made available, too, by the Heartland's chip area here in Indiana and Illinois.
From Purdue, our role is to educate the next generation of workforce, to provide the talent that all of you, all the industries in the area will need. So we definitely take a lot of pride in coming up with innovative solutions to train the talent. So we of course, have the traditional ways of training through minors and concentrations and a certificate in semiconductors, but we're also innovating in this space with workforce. A couple of examples come to mind. One of them is an absolutely amazing partnership we have with Ivy Tech, the singly accredited college in Indiana, where we are running summer camps for high school students. So for the second year in 2024, this summer, we run a camp for 60 high school kids. And they spend half of the time a week on the Ivy Tech campus and a week at Purdue, and they learn about opportunities they have, hands-on training for the semiconductor industry. We definitely hope they'll choose to come to Purdue or to Ivy Tech to pursue this career. And I believe that's a unique program in the country when we're talking about the length and the depth of the program. Once they come to Purdue, we heard that many students have a very hard time finding an internship during their first summer. So if you don't offer them an internship during their first summer as engineering or science students, then they'll find other opportunities where they will never look back to the semiconductor industry. So we decided to work with our industry partners and create a semiconductor internship program that's offered right here on the Purdue campus during the summer. It's fully funded by industry, and we engaged dozens of students. This summer we had 100 students that went through this program, and I want to thank MediaTek, and I want to thank Dassault, and I want to thank SK Hynix for being some of the partners who made that possible. Students, as in their first summer, after just taking introductory engineering classes, they have an opportunity to earn $10,000 as part of this quasi-internship. As I said, fully paid by industry, and they gain hands-on skills that then they can use to gain entry into a career and further internships. If you are going to be around until tomorrow, you're going to be surprised by the buzz of activity. It's going to be an explosion of corporate activity happening on campus. Tomorrow and Wednesday, we are hosting the Industrial Roundtable. This is one of the largest career fairs in the nation that's entirely organized by engineering students. They are sold out at 400 companies. So 400 companies are coming to hire Purdue students. Sold out over 50 to 60 companies on the wait list who were not fast enough to participate, to sign up. About 10% or more of these companies are hiring students for the semiconductor industry for jobs related to semiconductors. We are organizing an info session with these companies to tell the students more about what they can expect, what it's going to be like, what opportunities are out there. I'm happy to report that as of now, we have over 400 students sign up to come to the info session. So those are the types of benefits that we offer. We create awareness in students. We create training programs, engagement programs from high school and onward, and then the best possible training they can get with our faculty and staff so they are ready to hit the ground running when you need them.
Thank you. And Patrick, let me ask our last question to also Patrick and Bill. And that is, we have different stakeholders. We have the national labs, we have the universities, we have industry. And if you could talk briefly about the role, the current role of the different stakeholders, as well as future roles of the different stakeholders as we grow in terms of the Silicon Heartland.
Well, thank you, and I really can't add much to what this excellent story about the STARS program. If those of you who are not familiar with Purdue's summer internship program for undergraduates, and I don't know if we emphasize that enough, and that seems very altruistic, but I would say part of the reason that I'm here today, why MediaTek and other companies are here, is because we need partnerships, because we have a real problem. This goes back to your previous question, but I'll rephrase it as like why we're attracted to Purdue and other schools that are focused on the problem. In 2000, the semiconductor industry was roughly $50 billion. Next year, it will be $580 billion. In 5 years, it will be $1 trillion industry. That's just chips, right? Today, right now, compared to 2000, we are producing as a country the exact same number, slightly less actually, of electrical engineers that we did in 2000, right? And this goes back to what I'll call Patrick's Law, but it's not as cool as Moore's Law, which is you can rest assured that innovation will happen, 100%, right? Demand from consumers, innovation's gonna happen. What you care about, and Purdue cares about, which has been really important to us, is where it happens. Because setting the conditions for where innovation happens is all we can really do. We can partner with universities, we can get state governments and federal government involved in trying to drive innovation to particular geographies, but count on it. Innovation is going to happen. I say this as, you've got 2 foreign headquartered companies who chose to invest. They could invest anywhere. We could invest, everybody in the world wants MediaTek to open an office. Everybody wants SK Hynix to do the most important memory technology in the world. No, full stop. Everybody wants it. What we have to change our mindset about is we have to tool to be attractive. We have to tool up to drive innovation to happen here versus somewhere else. And that's a competition. And we haven't been serious enough as a country to produce the talent. Some of you may be surprised to hear MediaTek, we do have a great footprint, coming up on 1,000 employees in the US, right? 80% of those employees have at least a double E. 25% of every new hire, the head of our office, Gary, here at Purdue is here today, 25% of every new hire in the whole company will have a PhD in engineering. So yes, we love STARS and it's great, but what we actually are excited about is Purdue tells us they're gonna double the number of electrical engineers they make. And we're like, this is the biggest engineering school in the world, thank you. We want it to be doubled because our industry is gonna double in under a decade. Think about that. Like, the ubiquity of technology is just gonna be astounding in the period ahead. So that's both a challenge, but we're doing the right thing with the partnerships. We just have to do more. We have to urgently get young people to choose careers in these advanced technologies because our lives depend on it. We have to get this right.
Well said. And not a whole lot I can add to what the speakers have said. Innovation is going to be key. Getting all of you in the audience to contribute together. It's going to take industry. It's going to take academia. It's going to take the national labs, all working together. I do think there's an element of IP security. I think it was brought up in the previous panel that is going to be needed. But with that said, it really is going to come down to workforce, right? That is going to be one of the big shortages that we do have. I think somebody said there's going to be a shortage of 70,000 engineers. And I will say, Purdue is at the forefront of developing that. They've recognized it. They've built a curriculum around it. There is a lot of work that needs to still be done in order to capture that. But they're putting their shoulder behind it, from the leadership all the way at the top, all the way down. I can assure you that. And they're creating the partnerships in order to enable that. And I think that's going to be a big piece of it and a big benefit for Purdue and this corridor once they do it. It will attract the companies that it needs to, and that will drive the economic growth that I think they're looking to stimulate here in this region.
Thank you. And so now I want to have a wrap-up statement, just briefly, from each of our panelists, and I'm going to be random. This gives me a chance. So, Christina, if we can start with you. Just a wrap-up statement about the Silicon Heartland. Woo-Sung, I really like that. So, yes.
I want to finish with the statistic. I looked up last night the average starting salary for an engineering graduate in 2024, and it's north of $80,000. I also looked up the average salary for a computer science graduate, and it's over $110,000. These are wonderful numbers. If you look at the average salary in Illinois and in Indiana, if we can do something to attract these students, to find jobs, create jobs, attract the companies that offer these jobs to stay in Indiana, that would contribute tremendously to how competitive we are, to how innovative we are. So that's our goal, train them, but also work with you to create the environment for the students to be successful right here next to Purdue.
That surely is a lot more money than I made coming out of college.
Okay, and Bill, let's hear your wrap-up as well.
So for me, this has been an absolute pleasure. Thank you for the opportunity. Regarding this corridor and the partnership that we've created, we started out with a partnership a few years ago with Purdue University, and it's continued. We've since signed 2 other partnerships that are directly related to this. We're going to continue to drive for the need of innovation, but also workforce development. This partnership, and we're looking for it to anchor where we're headed. We are a French-based company, but this is one of the leading partnerships that we have, and it is the largest one we have around semiconductors. So looking forward to continuing that with Purdue University.
Thank you. And Woo-Sung?
So in our SK Hynix, so this is just the first step in this area. We call that our SK Hynix catchphrase is just one team spirit. We'll make a one team. So just like so we call that every time Boilermaker like that. So then we got a so very great success in semiconductor manufacturing or also R&D in this area. Thank you.
Thank you. And let me have Patrick.
Well, I will echo thanks. I would just finish up by saying that the work that we are about here is really important, right? Getting it right, driving innovation. I'm very mindful, right? I'm a former Army officer. I worked in national security. Democracies and close allied democracies of the United States, we have a joint stake in owning the future and making sure that the most advanced technologies in the world serve the interests of free people and protect the interests of free people. Part of our goal in choosing to invest at Purdue, and I would say invest with Purdue, is to create an ecosystem just like the one that Woo-Sung, you made such an eloquent defense of. And it's hard. We're creating something that has never existed really at this scale in the Midwest before, and it's really important. So we're just glad to be a part of it. We're glad to be ahead of the line with all those other people coming to steal the engineers here. By having an office here, we get like an early crack, so we're excited about that. But anyway, thank you for including Media Tech.
Thank you, Patrick, and Soprano.
Yeah, so, let me just call it sort of Silicon and beyond Heartland and not just Silicon Heartland.
Okay.
I think build upon the multidisciplinarity of this place and don't forget the science that is going to drive all of this technology 10 years forward. And I think this place succeeds if collectively we can build up a startup ecosystem. I believe strongly there's been no major technology developed in the past 30 years that has not been spearheaded by the startup ecosystem. And I think for microelectronics and quantum and related technologies to go forward, we cannot miss that, right? So I would measure that as a success 10 years from now, to go back to this region and see what kind of a startup climate has grown up here.
Thank you. And I want to take this opportunity to thank all of our panelists. This was an excellent discussion, so thank you very much.
Thank you.